Testing 1, 2. Do I got sound now? And we're live. You can tell when we're live because I make mistakes. Thank you, Allie, for stepping in and letting me. 1, 2. Oh, we got it. There we go. That's good. I got sound now. I got sound. I could hear it on that computer over there. This is RockSim Live. My name is Tim Van Milligan. I am back again. Last week, Martin filled in for us, and I appreciate that you made him feel so welcome because I appreciate what he did standing in for me on such short notice. This is live. It is about 2 p.m. Mountain Standard Time, and yeah, we got people on the chat, and if you have any RockSim questions, RockSim Live is the place to ask them, because I'll answer them right here, right now. So RockSim questions, RockSim Pro, or the Launch Visualizer. I can answer all those questions, and in fact, I did have a RockSim question that came in. I had 2 of them that came in. But before I get to that, the chat is going. Let me see who's here in the chat. We have Terry Wheelock. He says that he's got a new RockSim designed on me channel. We have Chris's Rocketry and More says hello all. 3D Printer Guy says hello. I am watching from the UK. It's just gone 9 p.m. over in the UK. Cool, the sun is probably down. Mark Sell from Parker, Colorado. We have a question from Mark today. He sent one in via email. And then everybody's screaming at me for no sound, but now the sound is on and people are saying better. And we have Sweater Dog, and TW Space says hello. Hello. TW Space, I have not seen your name before, so this is good to have somebody new here. Let me share my screen. There we go. So here is my screen. Let me make this bigger so we can not get so distracted by all the stuff that's behind the screen. This is our website, apogeerockets.com. And this is where you can go and get down RockSim. You see right here we have a sign up for our newsletter. But here's the RockSim. This is the banner bar, and here's RockSim version 10. And if you click on this, it'll take you to a page where you can download the latest version. What we're talking about is also the Launch Visualizer, and we have, I'm missing a link. Well, down here, we have the RockSim Live training, which is what we're doing right now. And here on the screen, if you click on this, this takes you to our archive page. And on this page will be all of our previous episodes, and we are on episode number 136. Today is September 1. Last week, Martin talked about how to conceptualize rockets using RockSim. Martin is our designer here at Apogee, and he's doing some amazing things with RockSim. And so I hope you learned a lot. And so that he talked about, you know, what he does as he's designing a new rocket. He also talked about determining fin size for multiple stage rockets and changing the color of your parts. We have Rosa from Canada. Okay, so let me find my questions here. Like I said, if you have a question, there should be plenty of time to answer your question. Put it in the chat. Okay, so the first question comes from Chuck. He says, "Hi Tim, checking in early from Pittsburgh. I have a Launch Visualizer question that may have been covered in the past. How do you make your home site your default location? Mine is PSC 473. So that's, I think that's Pittsburgh Space Command, and he's NAR section 473. And how do you default to standard measurements for temperature and wind speed? I know there is a units button for later in the simulation, but I mean when you are setting your parameters before you go hit the launch button. He says, I'm unable to watch live, so I'll watch later this weekend. Thanks for all you guys do. Okay, so that's a really good question. So the launch visualizer. So the launch visualizer is the online version of RockSim. You can run your simulations in the launch visualizer, but you can't design a rocket. And the website for that is rocksim.com. That's where I am right now. And here I've logged in. So if you click over here on the side, if you're not logged in, it will say please log in. But I've already logged in, and I'm under, I can see that I'm logged in because it has my username, and it tells me how many credits I have available for launching. Okay, so his question is, okay, how do you select your launch sites and make them a default? So right now, this right here shows a rocket on the pad, and this is in 3D, and you can use your mouse, and I'm doing a left click and then holding down the shift key, and I can, rotate it around and look at the rocket from any direction. So you can see north, south, east, and west, and that's going to become important, particularly because the wind is coming in. Right now our wind is coming out of the west, blowing towards the east. But this is not the standard location. So the standard location is right here under this button called Launch Site. When you click on that, it's going to load a standard launch location. Now, this is our home site here it's actually located in Pueblo, Colorado, which is south of where I am right now. I'm in Colorado Springs. So this is kind of like a visual, it's actually a three-dimensional space, because so north is the solid black triangle, and if I zoom out enough, I can see, so here's Pueblo. So our launch site is southwest of Pueblo, and then if I go further north, here's Colorado Springs. So I'm almost like due north of our launch site. And this is the default site for the launch visualizer. Now, his first question is, can you change this? So when you start it, instead of being this launch site in Pueblo, Colorado, can it be your website? And the answer is no. You can't change it. We had to hardwire it in. And there was a lot of reasons for it, and I can't think of them right now, except for the one reason is that it helps to load faster when it knows one location. But how do you get to your launch site? So here's what Chuck is probably doing. He's probably going to choose a launch site. So there's two ways to do it. One is you can just zoom out, and you can see, here's the United States, and so he's near Pittsburgh, and it used to show, and we got a bug that's going on, because it used to show every launch site that we've put into our database, and for some reason it turned itself off. But here's Pittsburgh, and this is in Pennsylvania. But I do not know where the launch site is. But what you could do is you could keep zooming in, and you could, if you knew your location, and your launch site, you could find it on the Earth. And I'm looking for a good launch site here. There are so many trees. In Pennsylvania. It's not like Colorado. We don't have that many trees. So here's a nice launch site right here. And so say this was, your launch site, and you found it. You could make this your launch site by just double clicking on it, and see it puts a red dot, and that red dot indicates that's my launch pad. That's not only my site, but the actual pad location. So if I didn't want the pad location there, I wanted it over here by this parked car, I could double click over there, and now that's the new pad location. And then it forgot the old one that was over here somewhere. But the one thing you have to do is you have to confirm the launch site. So that's down here at the bottom. When you confirm the launch site, what's going to happen is it's going to change the latitude and the longitude. And I could do like confirm launch site, and you can see that it did that. So now, if your club was in the database, so you can go choose the launch site from the database, and like he says he's from Pittsburgh Space Command, so I think I'm going to try Pittsburgh Space Command. Ooh, look at that, number 473. So that would be this is going to be Chuck's fastest way because it's already in the database. So you just click on it, click OK, and you can see the map just moved, and it's downloading the data for that new position. And so that's a much better site than I had. And you can see that's his where he's launching from. Now again, if the pad location is not exactly there, say maybe he's launching from a high power pad and they move the high power pad out here, you double click and say that's my new location, and then confirm the launch site. Now, so you want to get to this as fast as you can the next time. Here is what I would do. I would say first I would position the launch pad where you want it, and then say save this launch site, and click that button right there. And you have to give it a name. And so, in Chuck's case, PSC 473 is already taken. So maybe you can name it something else like my site. I got the caps lock on. My site. And you can ignore all this other stuff. And, this, you can put a description in here. High power pad location, and then click submit. And what this does is it saves that location back into the database, but it's your database. It's not the global database that has all the clubs in it. It's for your personal database, and this database is stored on our computer, and it's associated with your login. So in order to do this, you do need to be logged in. And if you're not logged in, you can create a free account. And the reason we need you to, give up your name and email is so that we can reserve space for you on our servers. So you can do things like this, like save your own launch locations. Okay, so once you're in there, so now let me zoom out. Let me put the launch pad way over here somewhere. Now to find that location again, I'd go to choose the launch site, and now you want to click over here to where it says private. So these are the public launch sites. Here is the private. So private means your database that we've reserved for you. So if you click on that, these are all the ones that I personally put into my database. And the newest one will always be at the very bottom. So here is my site. If I click on it and click OK, you can see it. The map moved, and if we zoom in again, it's right where we had put that launch pad. So when you open the launch visualizer, it's going to default to that launch site in Pueblo. Go to choose a launch site, go to the private, then scroll down to the bottom, find the one that you just saved, and it's got your name. The ones that you save personally are going to be in green. So that's an easier way to visually see them. And then just select it, click OK, and it will go to your pad. So it's a few clicks. It's not a default location that it's going to remember every time. Because when you first when you first come to RockSim.com, it doesn't know that you're logged in. So you have to log in first, and then come here to the pad, choose the site, go to your database, private database, then choose your site. So that's like 5 or 6 clicks that you're going to have to do. It's not too bad. Okay, and then his other question was about wind. Okay, so again on this one, okay, so I was thinking, so his question is, can you save a wind and temperature to a database so that you can recall it later? And the answer to that is yes and no. No, and by meaning no means you can't store both wind and temperature. You can only store wind data. So, you know, if you wanted, you know, a temperature every time you come here to be, you know, 70 degrees Fahrenheit, it's not going to save that. But we can, if you are a premium member, we can save your wind, what they're called wind tables. And these are custom wind that you set up. It's not going to be a default. It's going to be like the launch site where you have to select it, but it's pretty easy to select. Okay, so to do this, again, you're going to come down here to the Launch Conditions button, and under Wind Model, where it says Steady Wind at all altitudes, that's the default. There's also No Wind, and then here is Variable Direction Wind Table. And this is where you can store wind data. Because you can see up here at the top, we've got a wind table name, and we're going to be able to save this. So I might say Pittsburgh Space Command 473 typical winds. Okay. And see the button in the middle. This, we're going to click on that in just a second. So first, we're going to we're going to create a wind table. And now this wind table is a bit different from like a steady wind that we had that choice before. This wind table is we can have wind at different speeds at different altitudes above the ground. Not only blowing in one direction, but the wind can be coming from different directions. And you can do this in a custom wind table. So to set that up, we're going to start here. So the first one is altitude above sea level. This is not altitude above ground level. And so you have to make that distinction here, because our altitude currently right here at that altitude in Pennsylvania is almost 1,200 feet, 1,199.04 feet. So that is ground level at that particular launch pad location. So we can add and subtract data here. And if you click on this, I think, oh, there we go. If I click on it, I can change the wind. So at ground level, which is going to be 1,199.04 feet above sea level, my first wind, so now first I have to specify the direction. So if you look here, here's a little compass, and it's very hard to see, but Up at the top it says 0 degrees, and that's north. So east would be 90 degrees, south would be 180 degrees, and west is 270 degrees. So now you have to choose your compass direction. So if I wanted the wind coming out of the south, I would type in 180 degrees. So that means it's coming from 180 degrees and blowing towards 0 degrees. Because you'll see the little arrow right there is, showing it. This particular one doesn't move, but that's what's happening. It's coming out of the 180 direction going north. And then I have to give it a speed, and maybe it might be 4 miles, and I'm in miles per hour here. So now at 0 degrees, or at 1,299 feet above sea level, which is 0 feet above the ground, it's coming out the 180 direction at 4 miles an hour. So now at 2 feet above ground level, we don't have a speed here. So RockSim.com assumes it's 0. So you have ground speed, and then as soon as the rocket takes off, it's hitting 0 speed. So what we need to do is add more wind above ground level. And you're going to want to add how much above ground level? Well, how high do you think your rocket's going to go? And then pad it a little bit so that your rocket, you could fly bigger rockets sometime. Or you could go up to the waiver limit on your launch site. Maybe the waiver at this particular site is 6,000 feet. So my highest one would be 6,000 feet above 1,200 feet. So that would, so to add that, I would click on the plus button right here. Then you're just adding 6,000 feet to that. So that's 7199.04. And then I need to pick a direction. And I could, if you wanted a steady wind from 0 feet all the way up to 6,000 feet above ground level, you just choose the same direction and the same wind speed. So this one would be 4 miles an hour. So in this particular wind table, I have just a steady wind coming out of the south, blowing at 4 miles an hour from ground level all the way up to 6,000 feet above ground level. So it's a steady wind. It doesn't change. If you wanted it to change, you would come over here and you might say, at that altitude of 6,000 feet above the ground, let's say the wind's coming out of the north. And we'll leave it at 4 miles an hour. So basically, here's ground level, the wind, and then at 6,000 feet, it's coming from the other direction. So there's kind of a wind shear there. It's like it's blowing this way, but then eventually it starts blowing this way, and then all of it is blowing that way as it gets to 6,000 feet. So this might be, and I would give this a specific name, call it south to north. So you kind of can figure out what it is, and then we're going to save the wind table. And so now it's been saved into the database. So if I click cancel, and then if I go back to it, so here's steady wind. See, on steady wind, I can do the 4 mile an hour from the south at 180. You can see on this one, the compass actually moves. And I can change the direction by grabbing it as well. And you can see over here on the side that the wind is coming from a different direction on the rocket pad. But if I wanted exactly 180 degrees, I'd type in 180, hit tab, and click OK. So this is a steady wind from 0 to infinity. But now if I go back to my variable direction wind table, I can choose a wind table. And I had put in several already. I have this one called swirling wind. And if I click OK, you can see that this one, again, this is altitude above sea level. and it's 0 degrees, 90 degrees, 180 degrees. You know, it's swirling. But the one that we just created was PSC 473 south to north. I click OK, and it brings it up. Again, at ground level, it's coming out of the south at 4 miles an hour, and then at 6,000 feet above ground level, it's coming out of the north. And you click OK. And to see what that might look like, let's actually launch it, and we can show you what you're going to see. I want this rocket to go really high, so I'm going to choose the biggest engine that I have. And let's see, I want to actually choose the one with the highest total impulse. I'll choose this Aerotech D13, and a 10-second delay, and that's okay. And flight events, parachute coming out at maximum ejection delay. And there's a slider bar down here. There's more information. So whenever you see a slider bar, you can slide it to see more information. And then when you're ready to launch, down here in the bottom left is click to launch. And it says it's going to use 20 credits. I'll simulate it. And it's running the simulation, and it's going to load the simulation here in a second. It's got to load the map. I bet you my rocket is underground. Sometimes this happens where the map, you know, we thought it was 1199 above sea level, but the map and the actual Earth might be different, and so that's why sometimes your rocket can appear underground. If we launch it, you can see it came from out of the ground. I'll show you how to fix that. So now the rocket is taking off and it's going up, and let's see, it reached only about 2,000 feet, and now it's coming down. So I'm going to pause it right here. I'm going to change to a trajectory view. So I'm going to go over here to the camera and choose trajectory. Right now the rocket is somewhere up in the sky. This little white blob is the last remnants of the smoke from the launch. The rocket is, if you can't find the rocket, click on this button here. It says find the rocket in the sky, and what it does is it puts the rocket directly in the dead center of the screen. So if I zoom, oops, dead center in the screen, and if I hit the plus key, see, there's my rocket hanging in the sky. But that doesn't really show me anything. What I wanted to show was the how the rocket is moving with respect to the wind. So for that, I want to see the trajectory path, and I want to also see the extruded flight path. And then click OK. And so what it did right here is this green line is the launch of the rocket, is the path of the rocket going upwards, and these other lines are the path of the rocket extruded down from that point in the sky. So if we look at it from the very top, right there, so right here where my cursor is the launch point. And the rocket, when it took off, it kind of went to the southeast, and then now it's kind of traveling to the northeast or northwest. And does that make sense? Because what we said, we set this up in the wind, that the wind at ground level was going towards the north. So it comes out of the bottom of the screen and goes straight north. And so why does the rocket kind of go this direction? Well, the rocket reacted to the wind and it weathercocked into the wind. So then it reached its peak altitude. And then here's the peak altitude, is that green dot. And then at that point, you know, the parachute probably came out, and now it's descending, and it's still low enough in the sky that it didn't reach that point of inflection the point of inflection, since we made it exactly at 6,000 feet, it's going this way, and at ground level is this way, so the inflection point is going to be exactly right in the middle at 3,000 feet. Since we didn't get to 3,000 feet or above 3,000 feet with this rocket, it's only seeing wind blowing towards the north. And so if we continue the flight of the rocket, it's drifting that way. It's kind of like it should be going straight up, but it's kind of going to the northwest, and I'm not sure what's going on there. I think it had some velocity. You can see what we're looking at here is the top of the parachute. And you can see this is not a straight line. It's kind of arcing this direction. So we are getting some wind. Let me slide the slider bar all the way this way. Okay, so at this point, now we're going straight north, and that makes more sense. Yeah, that's cool. I wonder if I screwed up my wind. Let me go back to my launch conditions. Variable direction wind table. Yeah, I only have the 2. So it worked. I'm not sure why. Cancel. Let me go to my launch conditions here. I was launching straight up 0 degrees. And so the rocket reacted to the wind. So that's what it predicted, is that as it comes off the launch pad, it's going to kind of go not exactly south, probably because the wind is hitting the fins at an odd angle, and it kind of went off this way. And then the parachute came out, and it, I guess it is kind of it's kind of like, how do you change the direction of the wind? I think what it tried to do is to swirl the wind around. And so that's why we got a curved trajectory, just like that. If we look on it straight down. So again, well, if I look at it like from this, it must be just the angle I was looking at it from. I wasn't looking at it straight down. I'll go to 3D. Okay, so if I click on the 2D button and then zoom in, it does look like it did go more south. And then I could tell there's, like, right here is probably where the parachute came out. And then it started drifting that way. So Chuck, I hope that answers your question. You can save a wind table, but you can't save a temperature of the launch. You know, every time you would have to come over here and type in that new temperature, and then come down here to your table, your wind table, and then select that. It's not a default setting. That is a cool idea, maybe for a future version of the software, but we're not quite there yet. Okay. Oh, Terry Wheelock says, no, a silo launch. Okay, so how do you fix that where the rocket was coming out of the ground? Go back to your launch site, and where we had the altitude at ground coordinates, when we chose our launch site, what you're going to do is you're going to bump this number up to a higher number. So I might go 12 feet. So basically I moved it like 13 feet above it where it was before, and then click launch and simulate it and see if I'm above the ground. I'm still not above the ground. So I didn't go high enough. So go back to there. Sometimes, you know, I've had to do like 100 feet before. 1250. Simulate. When you get it high enough, you'll see the rocket above the ground. Still not seeing the rocket. This is a problem with the maps, and it's not something that we can fix because it's the maps are supplied by Bing. So the globe, you know, figure it's kind of like a mesh, a wire mesh, and that's the globe, and the globe has the terrain on it. And then you got by the maps, and you get the maps from Bing. We can't get them from Google. I'd love to get them from Google because they have better maps. But we get ours from Bing. And what Bing does, Bing has their own mesh globe. And so we have Google, Bing's mesh Earth surface up here and our mesh surface down here that we're using to run the simulations. And when they don't match up, the rocket appears underground between the two layers. So if you want it to appear above the ground, this is what you got to do. You know, you got to change your base altitude here. And yeah, let's see if we. You just got to keep doing it until the rocket appears above the ground. Still not above the ground. See, as soon as I launch, it pops up. So we got to be pretty close. See if I go back down to. Let's see if I can. At 0.1 seconds, it appeared above the ground. Or at least my flame did. Where'd the rocket go? There's the rocket. Yeah, 0.2, it says it's 29 feet, so I got to go 29 more feet, I think. Let's try 1,350 feet. See, if you look at it from this view, it shows your launch site way above the ground. This is the part that I don't understand, why it does that. Still not showing above the ground. I'm gonna really jack it up here. I'm gonna go 1,600 feet. See what it says is I'm moving my launch point way up above the ground, but why am I not seeing it? This is annoying. Maybe it's something to do with this particular launch site. That's bizarre. Let's try a different launch site. Let's choose a different launch site and see what happens. Let's do it. I'm just going to grab one out of the database. And launch it from there. Simulate. Let's see if this one is above the ground. Yeah, see? Come on. This one, I'm at least seeing the top of the launch pad. I was close. Let's see if I move this one up. You know, let's add 30 feet. 75, 97. Launch. Simulate. Find the rocket. I'll zoom in. It shows, well, I'm still saying this is driving me crazy. It shouldn't be like that. Let's try a different launch site, or maybe it's the rocket. Let's try a different rocket. Choose a design. Let's try an apprentice. to launch. Select the engine. Choose engine. D24. 7. Click OK. Launch. Simulate. Come on. I want to see the rock. I do not know what's going on. I'm just seeing the top of the launch rod there. And when the rocket comes up, boom, it just shoots right up out of the ground. Okay. Okay, so let me go to the next question. And this one was from Mark Sell. And Mark, let me see if I can find his question. He writes, I have a 4-inch diameter rocket that hard landed and cracked the body tube down 2 locations. To repair this, I have cut sections of another piece of body tube and am overlaying these pieces onto the outside of the rocket across the cracked area. They are going to look like access panels. I can't figure out how to add these in RockSim. Okay, so we won't need the launch visualizer for this. We need RockSim. I don't know what that was going on there. Okay, so I got RockSim, and it doesn't matter what rocket we use, just open one up. It's not looking in, where's the RockSim? We want to go to the C drive. Where is home? Where's my C drive? I don't want to go. What is this PC? Oh, there it is. Let's go to Program Files, RockSim 10. Here's Designs. Let's go Apogee, and let's try a Zephyr. Zephyr is a 4-inch diameter rocket. Okay, so here's a 4-inch diameter rocket, and his rocket cracked somewhere, and he's put like hatches on the outside of the rocket. So Mark, the way to do this, the most easiest and simple solution is, well, you got to think about it. What is happening here is you're taking just a panel and putting it on the outside of the rocket. So what does that panel do to the design? Does it change the aerodynamics of the rocket at all? Probably not. You know, just think of a piece of paper that's glued on top of your rocket skin. It's probably not going to change the aerodynamics at all. What other change would it affect? And the other thing that it could affect is the mass of the rocket. And that's probably something that you might consider, because the paper has thickness, it has volume, it has density. You're going to put some glue in there, so it is going to add mass to the rocket. So the easiest way is to use just a mass object, because a mass object adds mass, but it doesn't change the aerodynamic properties of the rocket. So what I would do, you know, I'd go to the side view and say, okay, I'm going to put my mass object right here. So I'll go to the design components, and you got to select where on the rocket you're going to put the mass. And I said I wanted to put it here. So if I click on that, what I selected is a body tube coupler, but I don't want it in the coupler. I want it on the tube. So here's the tube, and there's a coupler inside of it that joins another tube together. Now let's say that on this rocket I need to put it right there. So I'll highlight it and then come over here to Mass Object, click on the Mass Object. It always looks in the database first, and I always cancel out of that because it's not going to be in the database. This is our Mass Object screen. Let me make this bigger so you can see it. Okay, so right now it put the mass object right at the front of the tube. I want to slide the location backwards. That's like right there is going to be my panel. And now I need to tell RockSim how much this panel weighs. So before you glue your panel on the rocket, weigh it. You know, it might weigh 30 grams. So, you know, you just type in 30 grams and you've already set the location. And then you want to change the name of it, and you might call this repair panel. Oh man, I can't type. Repair panel. And that's really neat. All you need to do, it's going to be 30 grams, and you click OK. So now we have that, the mass of the panel that we're using to structurally reinforce the tube that was cracked. So that's the easy way to do it. If you've already glued your panel on, I would do somewhat of a similar thing, but now you need to weigh the rocket before you put the panel on, or at this point, you know, it's too late to weigh it before it's put on. So now you're going to do what you do for any mass object, is you're just going to find the weight of the rocket and then adjust it to include that new mass object. So let me go back to the mass object, which was right here. Let me click on it. Okay, so there's the repair panel mass. And if I change it to 0 and hit tab, click OK. Yep, it gave me an error. Let me give it 1. Oh, well, I can't. See, right now it says user specified. So that means I'm already overriding the mass of this rocket. So any new mass that I add, it's not really going to change anything until I turn this off. And I would say, let's just leave it at 30. So I'm going to just cancel it. Save my changes? No. So it's back at 30. So this user specified is specified here on this tab called mass override. And if I uncheck this, you can see that the weight drastically changed. So it went from 1540 to 1096. So it actually lost mass. This mass override confuses people like nothing else. I'm going to write an article specifically about mass override to try to answer these questions about, you know, what happens when you add mass to the rocket, or how do you add mass to RockSim. We've talked about this a number of times. I would prefer not to use the overall mass override, because it can cause confusion. Like even for me, you know, when I opened this design, I didn't notice this number. I didn't notice that it was user specified, which if I had saw that, I would have known that I had turned the mass override on. If this is off, then I could have easily added that mass and it would have affected the flight of the rocket. So with it turned on, you can add 1,000 grams and it's not going to change anything. So I can go back to this mass right there, the repair panel, and if I make it, you know, 1,000 grams, you know, it didn't do anything. It's still, the mass is 1,096 grams. So this is why I would prefer people didn't turn it on. If you turn it off, now you're going to see this is going to be a hefty weight right here because of all that mass right there. So let me go back to there and turn that mass back to 30 grams. hit tab. You can see that the mass dropped down and click OK, just like that. So that is how to add that repair to your rocket. You gotta think ahead a little bit. You say, I'm making a change to my rocket. Is it going to affect the aerodynamics of the rocket? Maybe or maybe not. And if it doesn't affect the aerodynamics, so maybe the mass, maybe you put those panels, instead of putting them on the outside, you put them on the inside. Structurally, it's adding the same strength, but that definitely doesn't change the aerodynamics of the rocket. So in that case, definitely mass object. So if it doesn't change the aerodynamics of the rocket, use a mass object. It is my catch-all for any changes that I'm making on the rocket. If it's going to make aerodynamic changes, then you might want to use something else. And there's not a lot of components in here in the components that will affect the drag of the rocket or the aerodynamics. There is one called a sleeve, and that one's right here, sleeve. So another way to do this, like I'll delete this, hit no, and oops, I want to delete it. I should hit yes. Okay, I got rid of that mass object that was right there. So maybe I want to put a sleeve here. A sleeve is a tube on the outside of the rocket. So, you know, we're just putting a sleeve on it. The problem in this case is the sleeve goes all the way around the rocket. And it doesn't, RockSim doesn't allow you to use just a portion of the sleeve. It's all or nothing. It's just one of those things. So again, where am I going to put that sleeve? I'm going to put it on that tube. And then I can select sleeve. And again, it always looks in the database, so cancel out of the database. So this is the sleeve screen, and the sleeve is basically just a tube. Come on, I can't grab that corner. There we go. Is a tube, so you'll look at an outside diameter and inside diameter, and it's already calculated the inside diameter at 4 inches because it knows that it's going to go over that 4-inch tube. So maybe it's like a 1/10 of an inch thick. So it's going to be 4.2 inches. Hit tab, and you can see it's drawn a line there. And then you got to give it a length. You can see I'm drawing it, and you can see that it's showing on the outside. Let me change the, well, first I'll select a material. Paper, I'm going to change the color. Let's make it red so you can see it. I make it red in both 2D and 3D. So here's it in 2D, and if I go to 3D, you can see that there's that sleeve. If I rotate it around, you can see the sleeve has a little bit of thickness. For some reason, it draws my sleeve as polygons. It's not nice and smooth like a tube. And that's something that we'll have to live with. But if I go to the General tab, and I can see that this sleeve weighs about 80 grams. Again, that's all the way around the outside of the tube. So that's why it weighs so much. You know, if I wanted to get it down to 30 grams, I would change either the thickness, which would be the outside diameter. You know, I maybe make it 4.1. This should about half of that weight. So it's going to go from 80, and as soon as I hit tab, it drops down to 39 grams. And then maybe I want to change the length. You know, I can make it a little bit shorter, get it down to 30 grams if I know that it's going to weigh 30 grams. You know, at 2.62 inches, that sleeve adds, you know, it adds that amount of weight. I click OK, and at this point you could run your simulation. But I can almost bet that the the simulation won't change much, except for we're adding weight. We can do a quick experiment here. So we'll choose an engine. Let's choose like an H100 white, 10-second delay. Click OK. Let's do deploy parachute maximum injection starting state. Need to change this to a 98-inch launch rod. Oops, come on, not 98. It's launched straight up, and we have an 8-mile-an-hour wind. Let's make it 0 miles an hour so that the rocket just goes straight. And launch it. And I want to give a comment on here. This is 30-gram sleeve, and launch it. And it goes 1,567 feet. And if we go back to our design components, now we're going to delete the sleeve. Really delete. I'm going to say yes. And then I'm going to add in a mass object of 30 grams so that I'm comparing apples to apples. Click cancel out of the database. I'm going to say 30 grams here because that's what we did before. And I need to see where I'm locating it. And I need to, I think before we had it somewhere right about there. So I'll just move it right about somewhere there. Okay, so basically it's kind of like the sleeve, but this time it's a mass object instead of being a sleeve. And if we run the same simulation, H100 launching straight up with no wind, and hit launch. Okay, so yeah, there's a difference here of about a foot. Yeah, so putting the sleeve on did increase the aerodynamic drag just slightly. You know, what percentage difference is that? It's like not even a 0.5%. My suggestion, if you want to do it, just use the mass object, because you could just drop it in there real quick, run your simulation, and see what it does. So let me pull that 30 grams out and delete it. Say yes, and then just rerun the simulation again. And you can see that the 30 grams, the weight, made a bigger difference. It made like 20 feet of difference, you know, from maybe 30 feet of difference. So weight is going to be far more critical than the thickness of the paper on the outside of the tube. So hopefully, Mark, that answers your question without it being too confusing. Terry has got a question here. He says, how do we make canopies in RockSim? Alfred Indy says, Terry Wheelock wants the canopy to go up looking like a canopy, but upon ejection, he wants it to transition into a streamer recovery system. Okay. And Terry also says, hey, can we design a rocket that can launch a rocket from on of the fins? Can we design a rocket that can launch a rocket from on the fins? Well, maybe. I had to think about that. I'll answer that one. So let's open up a design called the flying machine. Save my changes? No. Okay, so the flying machine. Come on, open. Oh, it crashed. On occasion, it still does that. Why does it do that? RockSim 10. Let's open that up. Windows PC x86. Go RockSim 10. Designs. Apogee components. And we can go flying machine. This time it'll work. Okay, so basically Terry wants to launch a rocket from a fin. So we could take a rocket that has a pod. So here's a rocket pod, and it is a rocket. And instead of putting it on the body tube, we will just attach it to a fin. So that is how you would do it. And we're running out of time here, so maybe I can do it real quick. So I'm going to my components, and I'm looking for my pods, and I'm just scrolling down, and I see the starboard pod, and I'm going to cut it out of the design. And when I cut, it's also going to save it into memory. And I say, really, doesn't delete this component? And I'm going to say yes. So it took it off, and then I'm going to go to my fin. I want that fin there. That's, well, maybe this fin here, because this is a single fin. And I'm going to put a pod on that fin. And let me make this bigger so you can see it. So right now the pod is on the tip of the fin, and we'll say, okay, click on that. So that's a fine location for it. And now I'm going to right click and paste. And did it paste it? No, it didn't paste it. Let me go to the other pod here and copy that one and paste it. It still didn't want to paste it. Oh, I know what's going on. You can't paste a pod onto a pod, but I can paste a pod onto a fin. Paste. And then delete that one. So that one was a mistake. Say yes. Delete. So it pasted a pod onto the fin. Let's see what it looks like in 3D, see where it is. There it is. So we have a rocket. Why am I showing it translucent? I must have made my tubes translucent. Oh, I turned trackball off. So I could launch this rocket and have the pod launch from the fin. So hopefully that answers your question. And then actually this will answer your other question again. He says, how do you make a canopy? And here's a canopy right there. If I click on it, you'll see it says canopy up here, but actually this canopy is a fin. So to make a canopy, why is this, where's the line here? There we go. So there's my fin. If I look at it from the side view, I can see that the shape of it, but if I look at it from the edge of the fin, it just looks like a line. It doesn't have any thickness. So then the fin, if you look at it from the plan points, let me turn it from the side again. If I look at it from the plan points, you can see, escape, that that's the shape of my canopy, although this one is upside down. But you can, adjust the shape to whatever you want. You can see when I move points around, it changes the shape of the canopy. So you just draw a fin, you just draw the side profile, whatever your canopy is going to look like. So then you got the fin, and then you go to the General tab, and you have to give it some thickness. And you can see here I gave it a thickness of 1.1 inches. Unfortunately, you can see it from the base view, what it looks like. And it doesn't conform to the tube, but in 3D, It does sort of look like a canopy, and that's as close as you're going to get to what the canopy is going to look like. Oh, that was quick. I hope that answered your question, Terry. From one of the fins, yes. Yeah, so to launch that rocket, then you just set it up like a regular launch. This is RockSim. So in RockSim, you wouldn't see it. You'd have to upload this design to the launch visualizer to actually see that rocket come off of the fin. So, so I would do a file, save as, and I'm going to throw it on my desktop. Flying machine, let's call it flying machine fin. Hit save. Okay, and then I'm going to exit RockSim and go back to the launch visualizer. Where was that? Where was that? Did I close it completely? I think I closed it completely. I think I was in Bing. Yeah, okay, so I'm in Bing. And to run that simulation, you go back here to select rocket, and I am going to upload a new design. I'm going to choose it by hitting browse. And I know I put it on my desktop. Here it is, flying machine fin. Click open and upload. And as soon as I'm done uploading, it will show the rocket here. So there's my rocket with the, so you can see the rocket is on the fin. So now we're going to launch this rocket, and we're now just going to go to choose motors. And we're going to start loading engine. So this one is then the core tube. So I'm going to choose an engine for that one. Let's call it E18-8. Click OK. Now we got two pods on here. I should have deleted one of them, because now I got to figure out which one is going to have the motor in it. So let's try this one first. And let's put in a C6. 7. Click OK. Let's see if I can see which one has the motor in it. I can't tell. I should have deleted one of these. Load them all. Okay, so so we want this rocket to detach. How do I get it to detach while the rocket is taking off and not provide the thrust to the this is I've done this before. Let's see what it looks like when we launch it. Oh, wait a minute, let me cancel this. I think I had an idea. So I'm going to the motors, and I want the motor to fire when I want it to come off. Yeah, let's see what it looks like first. Okay, so on this one, I can see the rocket just sticking above the ground, and when we launch it, it takes off, and those pods should fall off, but they've already burned out. They're in the smoke. Yeah, see, they fell off. Where are they? Let's go here, trajectory view. And let's turn the smoke off, because the smoke is obscuring things. Tracking smoke, thrust smoke. Find the rocket. zoom in. Okay. Just grabbing the screen. Gotta find the rocket in the sky, and it's way up there. There's the pods. There's one pod. Where's my other pod? Maybe that's both pods right there. There's something like right there. I zoomed in too much. Well, that one I'm going to have to think about, Terry. Launching a rocket from a fin. I've done it before. Anyway, we're out of time. And I've got another event to do after this. So, yeah, so that's the end for today. We will be back next week. Today is the 1st, so that has to be September 8th. Same time, 2 p.m. Mountain, 9 p.m. in London, or in the UK. It's Labor Day weekend, so everybody have a safe Labor Day. There's a whole bunch of launches going on. I know Airfest is going on in Kansas. It's probably going on right now as we're talking. We got a launch in Pueblo tomorrow, and Martin has come up with some designs that he's going to be launching tomorrow. If you're in Pueblo, you get to see what we're working on for the future. Very cool stuff. We're also going to be launching hopefully the Swing Shot, which is a J&H product. If I go back to the Apogee website, we started selling this Swing Shot. It's a glider that looks like that, and it's an RC glider. It's RC controlled, so it's 2 channels, so we can change the rudder and the elevator. And it's got a swing wing, so these wings pivot. Like we try to build every rocket that we sell, and this one we're finally getting around to flying it. In fact, Josh Finn, who is the J of J&H, he was here yesterday. He's in Colorado this weekend, and he also flies just free flight model airplanes, and he's going for a record, he said, up in northern Colorado. So good luck, Josh. If he would be down in Pueblo in the southern part of the state, he could probably see one of his rockets take off. So we're going to try to do that tomorrow. Very cool stuff. So have a great week, and until next time, I'll give you a countdown. 5, 4,